27, two ways of doing this question. You can think about, right, the whole process individually, part by part. So if you want to build this entire tower, right, you need to stack it up. So at first, right, you have to move this guy to this position, okay? And then you have to move this guy to this position, this guy to this position, and this guy to this position, okay? So what is the total gain in GPE in each of the step? So it will be equals to, so the network, right, equals to the total gain in GPE. So it's equals to mg times the first guy, right, will have 1h, second guy will have 2h, third guy will have 3h, fourth guy will have 4h, okay? In total there will be 10h, so it's 10 mgh, and this is method 1. Method 2, right, is to compare the average, the height, right, of the center of mass, okay, of this configuration. Suppose when they were all lined up horizontally, their center of mass, right, will be at the height of this level, which is h upon 2. Versus, right, when stacked, their center of mass will be at a height of 5h upon 2. So the second method, right, will be to consider, right, what is the difference between their center of mass, and hence, right, what is the difference between their respective GPE. So the change in the GPE, right, will be equals to the mg of the 5h upon 2 minus h upon 2. What about the mass? The mass in this case is actually equals to the mass of the total object, okay? Which is, I made a mistake earlier because each block is actually 2m. So here is actually supposed to be 2m, and this will be 20. So the mass of the, back to method 2, right, the mass of the combined object is everything, okay, which is equals to 10m. So you have 10m times g times 2h, so it's 20 mgh.